Pathshala. This is your chemistry period, and although we have finished this chapter, although we have finished this unit already, but now, as per your special request, I'm going to tell you about the most gray area, that is the periodicity in classification of elements. So, dear students, hope so this presentation will help you and you will enjoy the video. Okay, so let's start. As already we have done this modern periodic table, this you can see. If we will talk the modern periodic table, the most important periodic table is that this is the periodic table. Modern periodic table has made up of basically four blocks, that is S block, P block, D block, and F block. In which S block is first two group, it represents first two group, alkali metal group and alkaline earth metal group, and the last six groups represent, which is called representative group, P block, and the group number 3 to 12 is known as transition elements, that is D block, and the lanthanide and actinide series, which is in the transition group because it is found in between the transition group. Okay, so this you know very well. So now next, that is trends in physical properties. Now what is trends in physical properties, or you can say in simple word that periodicity. Basically the periodicity is what, dear students, we need to see the basic these properties, most important properties of modern periodic table. On the basis of what we are going to compare the different metals that is present in same group. Although we know that the classification made our work easy, why it make our study easy by relating like this way ki all the metals which is present basically in same group, they have same properties. It was we have already studied. Now we need to compare. Suppose group 1 is alkali metals, so all the alkali metals like hydrogen, lithium, sodium, potassium, rubidium, cesium, how these metals are same and what are the things that is different from them. Okay, so we need to study about the comparison, that is called periodicity. So down the group, which is down the group, there are 7 periods, and along the period there are 18 groups. Okay, so basically down the group and along the period we need to see first atomic radius, ionic radius, then ionization enthalpy, electron gain enthalpy, electronegatividity, oxidation state, chemical properties you will see. Okay, so let's see next, that is we will going to start with the atomic radius. The first property, that is atomic radius. What is the meaning of atomic radius? But basically three things you need to keep. One is definition, second is down the group what is happening, along the period what is happening. Okay, so basically so atomic radius is the distance, atomic radius is the distance from the center of nucleus to the outermost shell that contain electron. The center of nucleus, this is center of nucleus, to the outermost shell, this is outermost shell, which is called radius. Okay, in math also you have studied. If we will draw one circle, so the center, from center to outermost line is called radius, whereas the full line is called diameter. Okay, so radius is the half of the diameter. You have drawn the circle so many times in mathematics, so it is same, as it is assumed that the structure of atom is spherical, and the center is nucleus, and the outermost shell is the outermost radius. Okay, so this is called atomic radius. Basically it is the distance from the center of nucleus to the outermost shell containing electron. In other words, it is the distance from the center of the nucleus to the point up to which the density of electron cloud is maximum. Okay, so you know K shell, L shell, M shell, N shell, there are basic different type of shells. So I need to draw your attention on this diagram specially. So here you can see this side one line is there, which line is showing that the atomic radius is decreasing when we move from left to right. Atomic size is decreasing when we move to right to right, and atomic size is increasing when we move from top to bottom. Now question is that why it is happening. The atomic radius is increasing down the group because number of shell is increasing. As you know that when number of shell will increase, suppose this is K shell, then L shell, then M shell, then N shell. So it means that with the increase in number of shell, the radius is also increasing. Okay, with the number of shell, increase in number of shell, the radius distance will also increase. Because of that, down the group, it will happen in all the groups, all 18 groups. Down the group size will increase, radius will increase, and along the period radius will decrease. Now down the groups, why size will increase, radius will increase, that you know, because increase in number of shell. But why the atomic radius is decreasing along the period? That is because, as we know, number of electron is always equal to number of proton. And if number of electron is increasing in shell, so it means that number of proton will also increase in the nucleus. And from the center, When nucleus is increasing because of increasing proton, so it means that the space which is between nucleus and outermost shell, that will keep on decreasing. Because of that, atomic size will decrease along the period. Okay, so you can resemble here shape also, the circle shape. It is increasing toward down and it is decreasing toward left. Okay, so once again, the revision: atomic radius is what? The distance from the center of atom nucleus to its outermost electron is called atomic radius. Radius decrease across a period. It measure the atomic size also. Radius increase down the group. Each row on the periodic table adds a shell. Because of that, it is increasing down the group. Hope so you understood atomic radius. Now next, we will see with the help of this graph. This graph is representing that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. It means that along the period it is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, so when we will move from left to right, so it is decreasing. You can see the graph is decreasing. It means that due to this decreasing graph, it proves that from left to right, atomic size is generally decreasing. Okay, atomic size is generally decreasing. So across the period, as for the element of the second period, it is because within the period the outer electron are in the same valence shell and the effective nuclear increases as the atomic number increases. Okay, the result of increasing attraction between nucleus and the electron. It is why it is decreasing, because the attraction between nucleus and electron is increasing, and atomic radius decreasing left to right because of quantum number is increasing. It is also increasing down the group as the number of shell is increasing. Okay, so variation of atomic size, you can see down the group: lithium to sodium increasing. You can say lithium to sodium increasing, then potassium also increasing, rubidium to cesium continuously increasing. It means that down the group, lithium, sodium, potassium, rubidium, cesium are down the group. When it is moving down the group, the size is increasing, along the period it is decreasing. Second is ionic radius. Ionic radius is the distance from the nucleus of an ion up to which it has an influence in its electron cloud. So you can understand ionic radius only when you know what is the basic difference between atom and ion. Atom is without positive negative charge. Ion is positive charge. Suppose I am taking example of sodium. If sodium have 11 electrons, the sodium positive mean having 10 electrons. It means that one electron is decreasing from sodium, losing of electron. Okay, so here you can say anion is always bigger than its parent atom and cation is smaller than its parent atom. Why? Because cation losing one electron and anion gaining one electron. Again, parent atom, cation losing one electron, anion gaining one electron. So what is happening to ionic radius? Ionic radius is decreasing from left to right and increasing from ionic radius is decreasing from left to right and increasing from top to bottom. Okay, so the ionic radius of an element is the element's share of distance between neighboring an ion in an ionic solid. Generally, cation are smaller than parent and anion are larger than parent. Already I told. So we will recapitulate with the help of this picture now. Atomic radius is positively charged ion. Let me zoom it. Atomic radius is positively charged ion which formed when an atom of metal lose one or more electron. Okay, positive charge will carry on any atom when it is losing one electron, whereas an ion is carrying negative charge when it will gain one electron. This is the difference. So positively charged are basically smaller than its corresponding atom, and anion are larger than its corresponding atom. So this arrow is showing increasing ionic radius from right to left, or you can say left to right. It is decreasing. Okay, so down the group it is also increasing as per the atomic radius. So ionic radius are removal of electron from one atom result in the formation of cation and gaining of one electron leading to the ion. Okay, so cation is always smaller than the parent atom as we studied, and anion is always greater than the parent atom. This is due to electron repulsion. Isoelectronic species are those species, this is very important definition. Isoelectronic are those species which have two or more species with same number of atom, which have two or more species with same number of atom on same number of valence electron and same structure also. So what are isoelectron? Iso word means same, electronic mean which have same number of electron, same number of valence electron, same number of atom, same number of structure, same structure also. This type of species is called isoelectronic species. The cation with the greater positive charge will have smaller radius because of the greater attraction of electron to the nucleus. Anion with the greater negative charge will have the larger radius. In this case, the net repulsion of the electron will be outweighed the nuclear charge. Okay, so here you can see diagram. Nitrogen have 3 positive, oxygen have 2 negative, fluorine have 1 negative. So it means that negativity is increasing. Here -1, here -2, here -3. It is a minus charges are increasing. Chlorine -1, sulfur -2, bromine -1, selenium -2. It means that toward this side, the atom ionic radii is always increasing. Okay. So next is difference between atomic radius and ionic radius. Basically, atomic radius is the radius of neutral atom, and ionic radius is the radius of atom or ion. Atom's ion can be calculated as distance from the nucleus to outermost shell, and ionic radius can be calculated by dividing the distance from two nuclei of its radius. Third basic characteristics differences is here neutral atom of the same element have same size and the atomic radius is equal to each other, whereas cation have smaller than atomic radius and anion have larger than atomic radius. Determination considering neutral gas atom of chemical element, and it here determine considering cation and anion with the ionic bond. Okay. So third basic property is ionization enthalpy, in which ionization energy denoted EI. It is the minimum amount of energy. Defined definition is it is the minimum amount of energy required to remove the most loosely bound electron and the valence electron of an isolated neutral gas. Okay. So what is ionization energy? Basically, it is the energy required to remove 1 mole of electron from 1 mole of gas atom. Energy required to remove 1 mole of electron from the outermost shell. So basically, which kind of element is removing electron? It is non-metal, which is removing electron from metal, and it is gaining electron. Okay, so here you can see example, 1 electron is losing from sodium, and how much energy is required to lose this electron, that energy is called ionization enthalpy. Very simple. Atom can become ion when metal is becoming cation when it losing 1 electron, and non-metal become anion when it gain electron. Both the case, how much amount of energy is required to lose the electron and gain the electron from outermost shell, that kind of energy is called ionization energy. So let's discuss. Ionization energy is the major amount of energy needed to remove the electron atom, and as the electron are negatively charged and proton in nucleus is positively charged, there will be an attraction between them. Positive and negative is having strong attraction between them. The greater the pull of the nucleus, the more away the electron will be moved from the atom. Okay, so this is the example that shown the proton and nucleus and electron have one force. So what factors are there for the ionization energy? There are basically some factors. That value of first ionization energy depend on the electronic structure, like hydrogen have 1 electron, helium have 2 electron, lithium have 3 electron. So as per this, 1 electron is lost by proton, the value of helium is higher than the hydrogen, because helium have 2 electron and both side the equal energy is there. There are now 2 proton in the nucleus. The nuclear charge is greater, so pull on the outer electron is large. More energy will need to pull the electron out of the atom. So this is having more ionization enthalpy than hydrogen. Similar way, lithium, like this way. Okay, which has higher energy? The third ionization energy of aluminum or third ionization of magnesium. So you know that aluminum is in third group and magnesium is in 2 group. Magnesium will carry 2 positive and aluminum will carry 3 positive. So third ionization in aluminum involve these 3 positive, and magnesium second group, it will carry 2 positive. Okay, so despite magnesium have 12 proton and aluminum have 13 proton in the nucleus, the more energy is required to remove the third electron from magnesium, because the electron being removed is coming from an orbital closer to the nucleus, which is more closer, more stronger is there is less shielding effect. Okay, and therefore greater effective nuclear charge. So here I want to take one example, like if suppose your house is near to the police station, and your friend's house is little bit far than the police station. So in which house the easily that thief will steal the things? Yes, your friend's house, because your friend is far than the police station. The stealing or the thief will not come nearby the police station. So your house is nearby the police station. It is same, like nucleus is like a police station and the shell is like a house. If K shell, electron is in K shell, it is very difficult to remove. If electron is in L shell, it is easy to remove, because those electron which is in K shell, they will shield the effect of nucleus to L shell, and electron is easily moving from L shell. That's why always electron lose from outermost shell, not from the innermost shell. Okay, so this is called ionization enthalpy. So very simple diagram has given, a graph has given here. The energy is always required to remove electron from an atom, hence ionization enthalpy is always positive. Hence ionization enthalpy is always positive. The second ionization enthalpy will be higher than the first ionization enthalpy. Yes, so you can see here lithium, beryllium, nitrogen. So lithium, beryllium increasing, then boron decreasing, then nitrogen increasing, then oxygen decreasing, fluorine increasing, neon increasing. Reason? Fluorine have only one electron in outermost shell, one electron required, oxygen required 2, nitrogen required 3, carbon required 4, beryllium, boron required like this one 3, it will lose 3, beryllium lose 2, lithium lose 1. So due to this, the ionization enthalpy is compared. Okay, so ionization enthalpy is basically third ionization enthalpy will be higher than the second, fourth will be higher than third, like this way. If not qualified is taken the first ionization enthalpy. We will find maxima at the noble gas which have closed electron shell, very stable electronic configuration. On the other hand side, minima occur at the alkali metal. It means that minimum ionization enthalpy is in alkali metal and maximum ionization enthalpy will be near to the noble gas. Next is this is the nucleus, you can say nucleus, and this is the effect of orbit. Electron are here in the outermost shell, there are some effect. Okay, that is called shielding effect. What is shielding effect? The attraction of electron toward the nucleus, the repulsion of electron from each other. The effective nuclear charge experienced by the valence electron in an atom will be less than the actual charge, and this is called shielding or screening of the valence electron. Very simple. Shield word, you know, when something is protecting, shielding, like raincoat is shielding you to get wet. Similar way, the inner electron, inertial electron will shield the effect of nucleus to outer electron. Okay, so this is third property. So if you will see fourth property, that is electron activity, which is very important again. A measure, it is the measure of ability of an atom in a chemical compound to attract electron. It is the capacity, the ability to attract an electron. So here you can see this cartoon is attracting the electron of other energy of other two electrons. So this is the electron activity. This is representing electron activity. It is that atom, yeah, that force of atom which is attracting the electron. Electron activity tends increase across the period. Left to right it is increasing, and it is opposite to atomic size, and it is decreasing toward left toward down the group. Because why it is increasing left to right? Because radius is decreasing and electron get closer to the bonding atom. Okay, whereas in down the group, why it is decreasing? Because the number of shell is increasing. If number of shell is increasing, the electron is very far away from the nucleus, so it is difficult to remove that. Okay, so next you can see electron activity, it is increasing, sorry, toward left to right, and it is decreasing from top to bottom. So it means that which is here that have which is here that have highest electron activity in the group. If you will take, like, lithium have highest electron activity than the other member of the group, and francium has the least reactivity. Okay, whereas here lithium is least toward this left side, lithium is least, and fluorine have highest electron activity. Negativity mean the charge which carry. So basically non-metal is carrying negative charge, like fluorine have -1, oxygen have -2, nitrogen have -3, carbon have -4, like this. Okay, so dear student, quantitatively measure of the ability of atom in a chemical compound to attract shared electron to itself is called electron activity. Fluorine has the highest electron activity value of 4. It is the most electron activity element. So generally, okay, now next is electron gain enthalpy. It is what when an electron is added to a neutral gas. So let's understand with the help of their differences. Okay, there is difference between electron activity and electron gain enthalpy. It is tendency. Electron gain enthalpy is the tendency of an atom to attract outside electron, whereas electron activity is the tendency of an atom to attract shared pair of electrons. There is difference between shared pair of electron and outermost electron. Outermost electron is, suppose sodium have one electron and it want to release from outermost shell to become octet, to become stable. That is electron activity, whereas that is electron gain enthalpy. Whereas H positive and Cl net, yeah, you can say Cl when Cl is sharing one electron to Cl, yeah, H is sharing one electron to H. Suppose one electron is there, second H one electron. If they will share each other this electron, then it is called electronegativity. Okay, if H will remove share electron to chlorine, then it is electron gain enthalpy. It is the property of isolated element, whereas the electron activity is property of bonded atom. Electron gain enthalpy is the property of absolute electron attracting tendency, whereas electron activity is the relative electron attracting tendency. Electron gain enthalpy will be measured in kilojoule per mole, whereas electron activity doesn't have any atom. So electron activity and electron gain enthalpy, it is quantitative property, it is qualitative property. Electron affinity is quantitative property. Electronegativity can measured from Pauling unit, whereas electron affinity can measure by electrovolt. It is applied for a single atom, whereas electron affinity is applied for a atom or a molecule. Okay. So fifth and last property is oxidation state. An oxidation state is a number that is assigned on an element in a chemical combination. The number of representative of a number of electrons that an atom can lose or gain or share when chemically bonded with an atom. Oxidation state is what? The balance equal to the number of electrons present in an outermost shell. The term oxidation state interchangeable mean balance also. Valency you know very well, like hydrogen first group have +1, second group have +2, third group have 13th group have +3, 14th group have +4, like this way. So the term that is now oxidation to balance. Fluorine has the oxidation state -1, but in compound like OF2 it exhibits +2 oxidation state. So valency is the number of electron transfer or required or gain or lose, but oxidation state is number that is possessed after losing electron, okay, or gaining electron. Oxidation state determine the oxidation number of element that we will do in next sixth chapter also. So these were the five properties, physical properties of periodic table. Now if we will talk about chemical reactivity, there are only generally 2-3 properties. Number one, diagonal relationship. So usually it was taught to us that periodic table have same property down the group or same type of nature along the period. But there are some diagonal properties also, like lithium is related to magnesium, beryllium is related to aluminum, and boron is somewhere related to uh, silicon also. These characteristic properties shown in S and P block only. These properties are called diagonal properties. Okay, metallic character decrease from right to left. It means that most metal are in this side, then it is decreasing, and this is due to addition of electron in various orbital. Element will combine, which combine on the two extreme of the periodic table form oxides like peroxide and superoxides. Okay, those elements which combine on the two extreme of the periodic table, like first left side, last right side. It is talking about alkali and halogen. They will form superoxides and peroxides also. Some are acidic, basic and neutral, and some of they are amphoteric, which behave both acid and as well as base. Metal form basic oxide and non-metal form acidic oxide. This you studied in 10th class also, but still again, metals are forming basic oxides. If metal react with oxide, it will form base. Non-metal will react with oxide, it will form acidic. Okay. So among transition metals, the change of atomic radii is much smaller as compared to the representative element. Okay, mean in D block element, the atomic radii is much smaller as comparison to the representing element across the period. The change of atomic radii is still smaller among intertransitional metals in F block, and the ionization enthalpy are intermediate between those S and P. Okay, so conclusion is very simple. Electron shell, number of electron shell remains same when we will move left to right, but it increases when we move top to bottom. Valency is increasing by 1 when we move left to right, but it remains same top to bottom. Electron activity increase, the ionization enthalpy increase, electron affinity increase. So these three increasing from left to right, but decreasing from top to bottom. But characteristics of metal is decreasing with atomic mass also, atomic number also, atomic size also is increasing toward left to right, but metallic character, non-metallic character is decreasing top to bottom as atomic radius will also decrease. So there are some merit and demerits of periodic table. First merit is it is based on atomic number. Second, position of elements are related to electronic configuration. Electronic configuration is very easy to identify with the help of modern periodic table. Periodic properties shows gradual variation in regular interval. It is easier to remember, understand, and procedure. Okay, these are the merits of periodic table. As in yesterday, also this question I asked, and many students they have not solved, so better learn from here. Demerit: position of hydrogen is not satisfactory still. Fail to accommodate inner transition elements. They are kept inside. Okay, the F block. Few elements are not arranged according to their electronic configuration. This is also one of the major problem. So dear students, this is all about for today. Hope so you understood now again this periodicity of properties, and watch this video 2 times, 3 times, 4 times, as more as time from my YouTube channel until you will not understand. And don't forget to subscribe that channel also. Thanks for watching this video. Stay home, stay safe. This is my appeal from you, as nowadays the case of this coronavirus is increasing day by day, and we are unlocked now. So now we need to behave like corona warriors. We need to protect ourselves. We all are now corona warriors. We are not depending on others. We have to protect, we have to prevent, we have to take all the precautionary measures. Ask your parents also, if they are going out of the home, to take care all the precautionary measures that our government has instructed to us. Okay, use mask, use gloves, use sanitization, and stay home, stay safe, take care of your yourself, take care of your family also. Okay, have a nice day. So till my next video, again, keep enjoying digital classes. Thank you, thanks a lot, have a nice did. So thanks for watching this video. Have a nice day. Stay home, stay safe, take care of yourself. Thank you, thanks a lot.